Andrew Tuckman from Vision Recycling. We have Aaron Majors from Cagwin and Dorward. We have Conard Lindgren from PWP. And we have Marcia DeLonge from UC Berkeley. And Vic Claassen on the end. Andrew is the Business Development Director of Vision Recycling, which is a leading advocate for sustainable landscape and compost use in the East Bay. Vision Recycling creates and sells recycled mulch, compost, bioretention soil, wood chips, and soil amendments. Going down the list, Aaron at Cagwin and Dorward. You have been focusing on a sustainable approach in your construction project, so he's going to represent the construction aspect. Conard has been a landscape architect for a long time, has worked on very significant sites such as the 9/11 Memorial, and is experienced in very technical, difficult environments and products. Marcia has been involved in some very interesting work up in Marin in terms of how to redevelop soils in grassland habitats. So she's coming from a very detailed scientific background. Vic Claassen is from UC Davis. He's a soil scientist, and he deals with soil in more in not necessarily in urban situations, but in pretty much in everything else. Is that right, Vic?
Yeah.
Yeah. So
if it's not soil, that's my soil.
right. So I wanted to, before we get into specific questions, I think, thinking about how we deal with soil as landscape architects, there seems to be sort of three big issues. One is how much to work with the existing soils or not. And that can be complicated by the variation that's in existing soils, the impact from construction, and this is going to be more Aaron's thing, the contractor experience and quality. What I would like to come away with from this presentation is what are the successful and perhaps unsuccessful methods that people have been working with. Basically what works and what doesn't. And then maybe as a follow-up is what are the three most important things that we as landscape architects should be doing in terms of working with soil. So I'm going to start it off with the scientific perspective. And I guess this could be for either Vic or Marcia. So when many times in our projects, be it urban or residential or multifamily, we're dealing with a situation where there's compaction caused by construction. So there might be fine soil that's gotten compacted, or it hasn't been really stored properly. So my question is, sort of regardless of the size of the site, one can end up with something that's highly compacted and it's essentially a giant planter. So what can we do to reestablish a healthy soil profile in those sites that have been impacted?
I work on non-soils, deep excavations, mine lands, landslides, ski run, contouring, that kind of thing. So when I hear the word compaction, the first thing that comes through my mind is we have two soil properties to regenerate to get around that compaction issue. One is when the big storms come, we have to have a rapid way to get the water off the surface and percolate it down. You can do this with a coarse gravel, of course, like a French drain, but in the case of a fine and compacted and non-structured soil, you pretty much have to rip it or fracture it in some way, and we're talking about big enough fractures for the water to go in. So however you do that, if it's really a narrow spot, you've got problems. Well, we've jackhammered, we've done backhoe pits. Just don't run a rototiller over it and find it out too much, because then it just glues back together. The second aspect after you get the big fractures is to have enough fines in there where the roots can go down the big fracture and then press against some of those finer areas to get enough water to grow through the drier periods. Now the thing to recognize right away is that many of these sites are going to be irrigated, and mine pretty much are never irrigated. So I'm really interested in getting roots deep, and then finding some slower source of water to soak up. When I have a compacted soil, I fracture it, and I don't blend or mix it up too much, because that just makes it reset up when it gets wet again. So that's my shortest, concise way to fix that problem. And if those soils are going to go to mush, put some organics in them. That's critical too.
Okay, I'll just add to that a little bit. So I work on definitely the real soils. So I work on grasslands where these grasslands, these are all grazed grasslands that I work on, so they do experience some level of compaction from farm equipment sometimes, and also from cattle. And I would say you might need to take some of the steps that you just heard about in order to get plants growing, but once plants start growing, they'll help you take care of that compaction themselves, as long as you give them the nutrients that they need to grow. So the roots, as they grow over time, will help you deal with compaction in the longer term. So that's something to think about. So try not to overdo any disturbance that you're doing to the soils. We think a lot about soil as a carbon storage pool. So if you're thinking about green landscape architecture or minimizing your carbon footprint in any way, soils store a huge amount of carbon, and any disruption that you do to them is going to release that carbon into the atmosphere. So that's a problem if you're trying to think about your greenhouse gas budget. And the organics is the thing that we've mainly done in my project also. So by adding compost to grazed grasslands in Marin, we were able to increase the production of the plants by 50% in 1 year. And that's above ground, and that's also below ground. So that's working to work on compaction and working to improve the soils and just build them through only the plant's effort alone. So those are just some little things to think about kind of once you get your plants growing again.
I can add to that. You hit on the mechanical perspective and you hit on the organic perspective, and I think both are effective in different situations. But I like the organic perspective because it doesn't disturb the soil. You need organic anyway to grow your plants, and it's moving our soils from a synthetic approach, mechanically mixing them, introducing nitrolyzed sawdust was the old way, and then synthetic fertilizers to maintain plant health, and getting away from that and looking at, well, how does nature do it? And looking at the trophic levels in nature and how we move from the grasslands to forests, more and more organics and more soil biology. And the soil biology is what opens up pore spaces in our soils naturally. So that's it's a lot of science behind it, but for a contractor who's not a scientist, simply getting the organic matter that has all the soil biology in it, or adding to that soil biology with compost teas, and letting nature do its work to open up that pore space, it's that simple.
By the way, I love that this panel is embracing the word organics and compost. So happy.
So I have some follow-up questions for that. I'm going to just start with Vic since you started. So Vic, you're talking about two things. One is deep fracturing to get the roots in. So based on that, all you're doing is opening up the soil. You're not taking off any. You're just making large cracks and cavities for roots to get down. Is that how I understand it?
Yeah, that's what I said. The first inning of the game. But I think we're going to hear some structural soil comments here in a little bit. And I do not have structural soils. Mine are kind of anti-structural. And by cracks, they don't have to be big things you can stick your hand in there, but we're talking 1/8 inch, 1/4 inch, just bigger than the micron-sized pores, which are in a compacted volume. And if I can get the initial fracturing in, I reduce my overland flow and runoff issues, so that's a big thing. And I get the roots down into these fractures so that the plants can start doing what the normal soil pasture lands do, which is hard for us on these mine lands. The reason they stay chronically bare is because they just stay in this loop of losing as much soil as they create every year, and they're what's the word, bulimic or something. They just can't quite get it going. Yeah. And it's sad because there's always off-site impact somewhere. Somebody down the hill is getting sediment and metals and whatnot. So my ripping trick is to make that artificial soil structure to get the roots in. If you have a regular soil, don't mess with it because it's already kind of working. Even if it's a weed patch, it's already working. But in my case, these are made soils or Caltrans roadways or big pads, building pads, anything like that that's taken away all the soil. That's the part where we're talking about. And I'll give you a little just proof of concept. This idea of opening up a soil volume is an anathema to the geotechnical people because it creates global instability, and we're going to wash this all down the hill. And maybe if we show slides later, I can show you that what we did is to say if you put that fractured area on a level bench, the vertical forces are vertically. So essentially what you're doing is you're digging out a step and putting the soil back on it, and then it won't slide off the hill when it gets wet. Does that make sense? Instead of having a fluffy surface layer that washes off, these are all on steps and they stay in place. And we got the Army Corps of Engineers to do that. The only deal is we had to not call it ripping, which sounds awful, but we chisel now. But this is different than the structural soils because that's a whole engineered body right there.
So I have a follow-up for Marcia too. You're in a pasture, you're in grasslands, but you're adding compost. And the reason to do that was because the grasses they'd gotten overly compacted by and what kind of compost?
Okay. The kind of compost that we were using was just a commercially available yard waste-based compost. The reason that we added the compost was actually just the question came up from ranchers in Marin if they thought that they could store additional carbon in their soils. That was the only thing that they were interested in as a first step. They were thinking about it from the carbon credit perspective that kind of people were starting to think about 5 years ago or so, and also just people concerned about climate change. The surprising benefit that came out of this effort was the really substantial increase in biomass in the plant productivity, which of course is feed for their cows, so they love that. And then also in the root production, which is underground, which means that the soil is becoming healthier every single year. It holds more water, so that's better in times of drought. It's also better for just water management when we get a lot of rain to make sure that it stays in the soil and it's available to plants. Reducing temperature, so keeping the soil temperature better. It's just a way to kind of making sure that your soils are functional in the long run in the way you want them to be, best for the plants and more biomass every year. So the reason was just to store soil carbon, which we were actually able to show we've done, that we've actually increased soil carbon through this every year. More plants, they're sucking carbon dioxide out of the atmosphere, they're storing it in their roots, they're storing it in their leaves. Those are dropping at the end of the year and becoming part of the soil. But the side benefit was the increase in plant productivity and all those other wonderful co-benefits that happen on pasture land.
Are we going to see that wonderful image today of the...
I think it is on the slideshow.
Okay.
So if I'm working on a project and it's down in, let's say, Fremont, and it's on bay mud, you're telling me that we should just deal with that soil? We're supposed to not try to amend it? This is I'm just sort of tossing the stone into the water here. Because let's say it's a commercial development or it's a hotel or whatever it is. And so there's a level of expectation in terms of what they want, let's call it an ornamental landscape to look at. So You know, a lot of the soils in this area are terrible. So I hear Marcia and Vic saying, don't remove them, there's problems with that, and I understand that, but then we have to grow certain kinds of plants that maybe don't like that, or should we totally change the plant palette so that it's more suitable to that? So maybe that's, I'm just gonna, whoever wants to address that sort of from worst case or more practical standpoint can take a stab at it.
I'm gonna jump in here and just say that. Well, most of the time that we're given, you know, and the big theories are great for coming in and being able to get a D8 out there and a 3-foot spike and drag that across and rip this stuff up. And we'll be dealing with a landscape where we're engineering a site, we're reforming the land. We have our geotechnical engineers out there telling us that we got to put in 6-inch lifts compacted to 95%, and we'll end up with a rough grade that will be handed over. And then we'll be coming in to do our landscape installation of some big box trees and you know, our different other ground covers and shrubs we'll be putting in. And basically we're planting these into this 95% compacted condition, which you start putting some water in there, you find that there's a zero percolation. It's just, you end up with failure. And so when we're designing these projects, we're trying to develop overall soil profile given these kind of rough starting points of an engineered site. One way of doing it is to remove all that over-compacted stuff, get down and import a great soil profile that you grabbed from, well, a grassland.
Thank you very much.
And that's one way of doing it, and it has pretty good results. I mean, there's the infamous Disney mix, a blend of, you know, it's a sandy loam with a good organic quality in it, and the plants thrive, and you end up with a successful project, and everybody's happy. It's kind of similar on what we're doing with these bioswales or bioretention. Typically, we're importing all that material to function in this capacity that we've created this criteria for. It's, you know, or we're in a condition where we're in an extreme urban environment, we're on structure, and again, we're having to import. And that makes things a little bit more scientific, a little bit easier. We can pick where we want to take it from and put it in a truck and bring it where it has to go. And then, but then getting back to what Scott, you were mentioning, is when you're given the site conditions of what to do with your on-site soil, and then beginning a process of conditioning that material to take it from a high clay content and trying to turn something into Class A topsoil. Class A topsoil being a combined silt and clay of less than combined 25%. So you're up into 70% sand. It's a high sand content. We're not going to find that down in the Silicon Valley. You know, so you're importing sand. You're blending this stuff to incorporate the sand, to blend it, even though we have the soil structure. And these are all just kind of dilemmas that I'm spouting off here. To incorporate that sand into the clay, you could take the clay and roll it in the sand, and you end up with this little snowball. But to incorporate, you have to break it down, and there you're destroying that soil structure, and then you're trying to rebuild it, and then compound that with that you're using a subsoil or a dead material, and how to bring the life back into it, and then when you're done with all that, to put it into a condition where it's not going to recompact, or in the process of placing it, become overcompacted, and working with contractors who are looking at you like you're crazy, telling them they have to wear snowshoes when they're walking around to put the plants in. But these are the things that really make the soil work. You don't have to.
I can comment.
I've never worn snowshoes. I've never been asked to wear snowshoes.